In this session of m squared m cubed or 2, Mrs. M's Math to the Masses in a minute or two, we're still looking at probability, we're still looking at conditional probability, and today we'll specifically look at interpreting two-way tables and how to pull the data to set up the probability. And this is an important skill. If you're already studying for SAT, ACT, any of the testing, you'll see that this concept does come up, and it's something once you understand how to interpret the table, should be easy answers to get. So in this first example here, it says a table that records data that pertains to two different categories is a two-way table. In this example, the table shows the results of a poll of 50 randomly selected students who are asked whether they prefer to watch hockey or football. It says find the probability that the person randomly selected prefers football given that, remember, we always read the bar in between is given that they're a girl. So in my denominator, I need to put total girls. And if you look at your table, you would add your 6 plus your 16. So I'll put that in the denominator. And then in my numerator, I have to find who is a girl and likes football. And here's my chart. Girls who like football, there's 6. So that gives me 6 over 22, which does reduce to 3 over 11. That would be equal to 0.27. Let's see if I'm off my paper. And when I multiply times 100, that's 27%. There's your answer to the first question. For the next question, they say the probability of a boy, given that they like hockey or prefer hockey. So you come over here and you say there's a total of 10 plus 16 in our random survey who like hockey, but the probability that it's a boy who prefers hockey, you can see on the chart, your numerator would be 10 boys prefer hockey. When you do the math, you're going to get 5 over 13 becomes 0.38, which is about a 38% chance to answer that question. I'm going to flip papers, and we now have a few more tables and questions to look at for examples. Push pause and move on to your own assignment once you understand the concept. But this will give us quite a few to work through as examples. So now we're looking at a table that shows results of a poll of 150 randomly selected middle school students who are asked if they take French or Spanish. So in the first question, it says, what's the probability a 7th grader who takes French? Out of this 150 you randomly draw, there's our total, that we choose one who is a 7th grader that takes French. Come over to your chart. Here are all your 7th graders, but it's 25 that take French. When you reduce that, you change it to a decimal. There's your repeating, 0.166666, which is about a 17% chance. Now let's try and get an 8th grader given that they take Spanish. So for my denominator, I have to figure out who all takes Spanish. If I add up 23, 12, and 33, I'll get 68. That is my denominator. But an 8th grader out of this would be, there's 33 8th graders who are out of all the kids who take Spanish. That reduces to 0.49, which is about a 49% chance of meeting that criteria. Next, we're trying to get the probability of randomly selecting a student that takes French given that they're a 6th grader. So let's go look at our chart and let's find all of our 6th graders. We have 19 plus 23. I'll write that down so you can see where it came from. On the top row, all your 6th graders, but who takes French For our numerator, we want the 19. So this gives us 19 over 42, which becomes 0.45, multiplied by 100, about 45%. Okay, so now we're going to try and look at finding a 7th grader, given that the 7th grader takes French. So we need everyone who takes French first to look at. Our denominator would have to be adding up 19, 25, and 38. Give us 82. And we're looking at a 7th grader. So we go, there's 25 7th graders who take French. That becomes 0.30, or about a 30% chance of meeting that criteria. You can push pause and look at that. Here's our next example. We have a table that shows the results of a poll of randomly selected juniors and seniors who are asked if they attended prom. So what's the probability a junior that did not attend prom? Okay, so out of this 150 total, is that right? Oh no, we don't know how many. That was the last example, so we better find out how many total people. So a junior that did not attend prom. The table shows the results. So we asked juniors and we asked seniors. So we asked a total of 84 juniors and a total of 116 seniors. And we add that together, we do have a total of 200 people we're considering. And juniors that did not attend prom, here's our juniors, no prom, that's a 56 on the table. So that's a 28 over 100, which would still reduce, that goes down. A 14 out of 50, because 2 goes into both of those, which becomes 0.28, about 28% chance. Okay, next, what's the probability that someone did not attend given that they're a senior? So we have a total of 116 seniors we're considering and did not attend. That would be the 19 for the numerator. That becomes 0.16, about a 16% chance. And for our last example, probability of a junior given that they attended prom. So our denominator has to be juniors that attended prom. Let's see. So we've got 125 out of everyone who attended. So here we add up our, we'll do this, 28 plus 97 to show everyone who went to prom. But a junior who attended prom would be 28 right here. So that gives us 28 over 125, which equals 0.22, 22%. Okay, scoot down the page, do some more tables. The table below shows the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, or no bags. Okay, so in first class, right here we know we had 16 who checked 2 bags, 12 that checked 1 bag, 0 bags, there were 2 people. So we had a total of 30 people in first class checking bags, or not checking bags. In coach class, we had 52 people checking 2 bags, 60 checking 1 bag, and we had 18 people who checked no bags at all. We're trying to get our total counts on how many people we had. So this adds up to 130. If we're going across here, total amount of people who checked 2 bags, add up 16 and 52, and you'll get 68. Add up 12 and 60, and you'll get 72. Add up 2 and 18, 20. It is important to know your totals to have your denominator, depending on the question they ask. This would be 160. Total bags checked, total people. Okay. So now we have the probability, I'm going to switch colors, of getting a coach class passenger given they did not check any bags. So let's see how many people in coach class checked 0 bags. So we have a total of, I'm going to come down here, 20 people checked no bags, and the ones in coach, there's 18 out of the 20. They probably travel often and don't take much. That becomes 9 over 10, which equals 0.9, about a 90% chance. Okay. The next question is finding the probability a first class passenger was chosen given they checked at least 1 bag. So we have to look at first class passengers. We'll consider here that checked 1 bag. So how many people checked 1 bag? $72. We're going to come back to that one because I'm looking at something to my left that does not look correct, and I thought I'd caught all of it. So we'll come down here and work C and D first. So probability of coach class given that they checked 1 bag. So checking 1 bag is 72. Oh, this is the difference. Checked at least 1 bag versus checked 1 bag. That's why I was reading it wrong. So we'll come back to that. So definitely on the chart, checked 1 bag is 72. And coach class, we have a total of 60 who are in coach class who checked 1 bag. So 60 out of 72 chance. That's 5 out of 6 equals 0.83, or about an 83% chance. So now that I'm reading this one correctly, at least 1 bag, we're going to have a larger denominator, right? You have 140 who at least checked 1 bag because you're going 72 and 68. I'll put that underneath. That was 68 plus 72, checking at least, keywords at least. Okay, but they're first class passenger, and we had 28 first class passengers who checked at least 1 bag because we go 12 plus 16. So we have 28 over 140, which equals 1 out of 5, which equals 0.2, which is about 20%. And we have one last query down here, and it says, check 2 bags given that they are first class. So let's look at everyone in first class. There are 30 people. And we say check 2 bags given their first class. So that would be 16. That becomes 0.533, or about 53.3%. There are some good two-way table examples for you to refer to as you move through your assignment.